So notice in example 3, the instructions are a little bit different than example 2. Example 2 asked us to say where they're defined and then to simplify. This question just asks us to simplify. And we might notice in the question, and I'll put a yellow box around it, they've added where things are defined for us. So they did that part, but sometimes when students see this question, they're like, what do I do with this part at the end? That's just telling us where it works. That in this one with square roots, both m and n need to be bigger than or equal to 0. So some students go, oh, thank you for telling me that. I'm just going to ignore it now and solve. There are a few little things that, that do come into play, little tiny details. We'll see them in part C when we get there. Okay, so in part A, do we have like terms? Are they written as mixed radicals? Can we simplify them anymore? Yes, they're already mixed radicals that we can't simplify anymore. Do we have any of them that are alike? Yes. We have 7 root m's minus 3 root m's, leaving us with 4 root m's. We have 2 root n's plus 5 root n's, which would give us 7 root n's. And this is all we would need to do in A. Really nice when it's already pre-simplified. What about B? We have cube roots. We look inside of those cube roots to see if there's anything more we can simplify. We also have square roots. We look inside those square roots to see if there's anything more we can simplify. In this one, I am going to take the time to underline this one and this one in green, and this one in purple, to really highlight those are the ones that are alike. Can you see yourself being tempted to say they're all alike? Okay, but some of them are cube roots and some of them are square roots. So in order to be alike, they do have to be completely alike. So then if I put the green ones together, 2 cube roots minus 9 cube roots would leave me with minus 7 cube roots. And if I put the purple ones together, 8 plus 3 will give me 11. Now, in part C, again, I'm going to show all the work right now. If you're getting comfortable that you can skip some steps, that's perfectly fine. We do have to simplify these. So I'm going to have 3. I'm going to write 32 as 16 times 2. I'm going to write a to the 5 as a to the 4 and a. And I'm going to need to write smaller, I just realized. I can cheat a little bit. There we go. Minus 2. 45 is 9 times 5. B cubed, I'll break up with b squared and b. Plus 5b. 125 is 25 and 5. And I'll keep the b inside. I'm still going to run out of room. Minus 2a. 72 is 36 and 2. And a squared and a. Wow. So showing all my work takes a lot of space. So you can see why, if you can do things in your head, okay, and this is the stuff that I would say you would do in your head. Square root of 16 is 4. That means there's going to be a 4 out in front. There's already a 3 out in front. Should I write 7 or should I write 12? Are we multiplying or are we adding? For this first one, this is 3 times, we're multiplying. So when I square root the 16 and I get a 4, that 4 gets multiplied by that 3, I get a 12. Also, in front. I'm going to put a little check mark above the 16 and a check mark above the a to the 4. Those will be things I can bring out in front. The square root of a to the 4 is a squared. What's going to be left inside? Root 2a minus. Square root of 9 is 3 times 2 will be 6. This I can simplify. This I can simplify. The square root of b squared is the absolute value of b. However, in this question, you can just write b because we already know that b is positive from the restricted domain or from the where it's defined. So normally when you do the absolute value of b squared, it would be, normally when you do the square root of b squared, you get the absolute value of b. But since we already know that b is bigger than 0, we can just write b because we don't get into that problem of having a negative. And then we're left with 5b plus square root of 25. That's going to be 5. 5 times 5 is 25. B, I'm left with 5b minus square root of 36 and a squared. So square root of 36 is 6. So that'll be minus 12. Square root of a squared is a times another a is a squared. And I'm left with a 2a. Color coding this, can you see that this one and this one are alike? And this one and this one are alike. And the green ones that are alike are so much alike, they're identical, and one subtracting the other, that's going to be 0. So all we're going to be left with is we have minus 6 of these plus 25 will give me 19 of them as a final answer. So again, if you want to skip the step that you're writing everything out, just make sure you're checking your mental math as you're going along. Do your numbers separately and your variables separately. And question number 8.